Hello students, I'm back again. My name is Fizwell Hlachwayo from Umgungundlovu TVET College. We are continuing with our series of lessons, level 3 mathematics. We are looking at topic 3, which is space, shape and measurement, and we are still looking at subject outcome 3.3, which is the use of the Cartesian coordinate system to derive and apply equations. You will remember that we did lesson 1, we did lesson 2A, lesson 2B. Today we'll focus on lesson 3A and 3B. So in this lesson, basically, we are deriving the angle of inclination and we give it the Greek letter theta. So that angle is going to be represented by the Greek letter theta, which is just like a small zero which has been crossed in the middle. And then we are also going to be calculating that angle of inclination. Now, this angle of inclination, theta, of a line is the angle between the straight line and the right side of the x-axis. And theta can be acute or can be an obtuse angle. Let me show it on the board. If I have my Cartesian coordinate or my Cartesian system like that, and then this part, it is the positive side of the x-axis. Therefore, if I draw a line, then that new line, which I've just drawn, creates an angle. This is the angle theta, which is formed between that line and the right side of the x-axis. It is formed between the line or the graph and the right side of the x-axis. In this case, I have drawn an acute angle because it is between 0 and 90 degrees. You remember that this is a right angle, so this is a 90-degree quadrant. So this angle exists between 0 and 90, therefore it is an acute angle. Theta can also be obtuse. In other words, I can draw a graph like that. And again, our theta will be measured from the right side of the x-axis to our graph, like that, or whichever way. So that becomes our theta. And in this case, you can see that theta is bigger than 90 degrees, and therefore it becomes an obtuse angle. This was an acute angle, a small angle, acute angle, for you to remember that. So that becomes an acute angle and an obtuse angle. And therefore, we are going to be determining that theta when we are given some information on the graph. I've just explained that when theta is an acute angle, then theta is smaller than 90. And the gradient is going to be greater than 0, which means our gradient is positive. And when theta is an obtuse angle, it means that theta exists between 180 degrees and 90 degrees. And therefore, the gradient will be negative. In other words, it will be smaller than 0. When theta is an acute angle, this is a typical diagram that you will see. And therefore, this dotted line represents the change in y, or the y displacement. And this represents the change in the x. And therefore, if I have to calculate the gradient m of this line, it will be change in y over the change in x. That's how we have been determining the gradient of a straight line. y2 minus y1 over x2 minus x1, which is exactly the same as that. But now, if we go back to basic trigonometry, where we use trig ratios, the sine, the cosine, and the tangent, we use those on a right-angled triangle. We can also determine a trig ratio which has got theta to see how we can deal with that. Now, you know that we normally use so, ka, toa. This is the sine ratio, this is the cosine ratio, this is the tangent ratio. And from these ratios, the tangent ratio It is the one that involves the opposite side and the adjacent side. So from this, it means the tangent of this theta is equal to change in y over change in x. Now you can see that the gradient is change in y over change in x, and the tangent of theta is change in y over change in x. Therefore, we can conclude that the tangent of theta is equal to the gradient, because the tangent of theta is change in y over change in x. Gradient is change in y over change in x. Therefore, the gradient is equal to the tangent of theta. We can then say, therefore, what is theta? Therefore, theta will be equal to m times 1 over tan. And we know that 1 over tan is the arctan. Therefore, we can then say m times the arctan, which means we can rewrite it and say the arctan times m. Therefore, theta can come out from the inverse tangent of the gradient. So this is the equation that we can use to determine theta if theta is an acute angle. So this is a very important equation that we will be using throughout this part of the chapter, or this part of coordinate geometry. Let's now look at what happens when theta is an obtuse angle. Like I said earlier on, you can see that theta is bigger than 90 degrees. And therefore, even if we're going to create a triangle here, it will not be a right-angled triangle. So in the meantime, I've introduced an A, the angle that is formed between the left side of the axis and the graph, and I've called it A. And that becomes our reference point. It is our reference point because it forms part of the right-angled triangle. Therefore, I can then say the gradient of this line, it is change in y, which is positive, over the negative change in x. That becomes our gradient, which means our gradient is going to be negative, because a positive divided by a negative becomes a negative. And you can see that our line slants downwards, so it should agree with what I've just written there. And then the next thing is that the tangent of A is also equal to the positive y divided by the negative x, the tangent of A. Therefore, it means the gradient, which is negative in this case, is equal to the tangent of A. So I can write that and say tan of A is equal to negative m. I can write clearly like that. It means, therefore, that A, that angle, is, if we take tan to that side, it becomes arctan of minus m. Right, so we are initially dealing with the angle A, which is what we find in the right-angled triangle. But mind you, we are dealing with the angle of inclination, which is the theta. Now, you can see that A plus theta, they add up to 180 degrees. Therefore, from that information, I can say theta is equal to 180 degrees minus angle A. Right, so because A plus theta, they add up to 180 degrees, the angle is on a straight line, I can then say theta is 180 degrees minus the angle A. Then, just above here, we have an expression for A. Then I can substitute this A by that, and then it becomes theta is equal to 180 degrees minus the arctan of minus m. This also is a very important relationship. So we have that for the acute angle, and now we have got that for the obtuse angle. Then we can say theta for the acute angle is that, and theta for the obtuse angle is given by that. Then we are well equipped to deal with questions that involve theta and the Cartesian coordinate system. Let's move on to some examples. Right, so let us look at an example here. I have example 1, which is actually 1A and 1B. The example says, determine the angle of inclination, theta, of the following. A, the line passing through minus 2, 5, and cuts the y-axis at 10. Now, we are given these coordinates and that point. Therefore, we need to use that to determine the gradient. If this point is at 10, therefore the coordinate at that point will be 0, 10, because the x component is 0 and the y component is 10. Therefore, what is our gradient? M. It will be y2 minus y1 over x2 minus x1. Our y2 is 10 minus our y1, it is 5. Our x2 is 0 minus our x1, which is minus 2. That gives us 5 over 2. You don't necessarily need to change it to a decimal. You can leave it like that. And then we need to find theta. So we said theta, and you can see that this is an acute angle, so it becomes the arctan of M. And what is our M? Our M is 5 over 2. This, obviously, you will have to punch it into your calculator, and then if you do that, you will get your angle as 68,199 degrees. Our examiner normally would expect us to leave our answer to 3 decimal places. And therefore, even if they don't indicate that, you can always leave it in 3 decimal places unless the question specifically asks you to leave your answer in a certain number of decimal places. So that will be how you go about it. In our second question, or the B question, it says determine the angle of inclination, theta, of the line y plus 1 over root 3x is equal to minus 11. So let's write that equation. Y plus 1 over root 3x is equal to minus 11. So that is the equation that we are given. So like we said in the previous lessons, we have to rearrange this equation so that it is written in the form y is equal to mx plus c. And to do that, I will have to transpose this part. So y is equal to minus 1 over root 3x, and then minus 11. So that becomes the equation written in the form y is equal to mx plus c. You can see here that m, the gradient, is negative. Therefore, theta is going to be an obtuse angle. Therefore, the formula for theta for the obtuse angle is theta is equal to 180 degrees minus the arctan of the negative m. Now, we need to be very careful here. Then that becomes 180 degrees minus the arctan of negative. But our m comes with its own negative, so it becomes minus 1 over root 3, and then we close the bracket. This negative sign belongs to the formula, so that's the one that we are putting there. M is coming with its negative, so we need to indicate that negative also. And then, if you punch all this in your calculator, you'll get a nice obtuse angle of 150 degrees, like that. Quite straightforward. You see, this is a small trick that they are giving us here. They are not telling us a lot of information. But now we should be clever that they are saying it's a right-angled triangle, which means there will be two lines that are perpendicular in this case. Now, looking at the diagram, you will agree with me that the line QP would be perpendicular to the line PR. I mean, the line QR is the longest on this triangle. Therefore, it should be the hypotenuse. Therefore, the other remaining two sides should be the two sides that are perpendicular to each other. So let's try to prove that. Let's try to prove that the line QP is perpendicular to the line PR. And the only way to do that, it is to find their gradients. So let's do that. Let's first find the gradient QP. So the gradient M of QP will be y2 minus y1 over x2 minus x1. I will call these the 2's and these the 1's. So y2, it will be 2 minus y1, which is minus 4. x2 is minus 4 minus x1, which is minus 2. 2 minus minus 4 gives us 6. Minus 4 plus 2 gives us minus 2. And therefore, our gradient becomes minus 3. So that becomes the gradient of our first line. Then let's find the gradient PR. The gradient M of PR will be the same, y2 minus y1 over x2 minus x1. I will take these to represent the 1's and these to represent the 2's. So y2 will be minus 4 minus y1, which is minus 1, over x2, it is minus 2 minus x1, which is 7. That gives us minus 4 plus 1. That gives us minus 3. And minus 2 minus 7, it gives us minus 9. Two negatives give us a positive. 3 over 9, if we reduce it, it becomes 1 over 3. So this is the gradient of one line, and this is the gradient of the other line. Let's see if the product of these two gradients give us minus 1. Because if they do, then we can conclude that they are exactly perpendicular. So we'll use our M2 times M1 is equal to minus 1. Our M2, if we call it 1 over 3, and our M1 it is times minus 3. And you can see that if you punch this in your calculator, you get minus 1. Therefore, the line QP is perpendicular to the line PR because the product of their gradients will give us minus 1. The next part of the question, it is to calculate the area of the triangle PQR. Right. So the area of a triangle A is found by multiplying the base times the height and dividing that by 2. Some will write it as half the base times the height. It is still the same. So I will go back to my diagram. We have agreed that there is a right angle there. So I will take PR to be the base and PQ to be the height. But we don't know how long PR is, and we don't know how long PQ is. So we need to find the distance, D, of the line QP. And then we also have to find the distance of PR. And how do we do that? The distance formula, we talked about that when we talked about the pre-knowledge in our first lesson. it will be x2 minus x1 squared plus y2 minus y1 squared. If we look at the coordinates that we have for the line QP, we say these are the 1s and these are the 2s. So x2, it is minus 2, and then minus x1, which is minus 4. All this should be squared, plus y2 is minus 4, minus y1, which is minus 2. All this should be squared. If we punch all this in our calculator, it will give us the square root of 40, which we can write in said form, and it becomes the 2 root of 10. If you want, you can convert that into the decimal, and it becomes 6,325. So we now have the length of QP. I'm not going to repeat this calculation for the length of PR because it's exactly the same operation. But now, if you do the same for the length of PR, you will find that the length of PR will be 3 root 10. And then we now have the two lengths of the two sides. Now we can then introduce them into the formula and calculate the area of that triangle. We said area, it is half the base times the height, which means it will be half times 2 root 10 times 3 root 10. This you can easily punch into your calculator, and if you do that, you will get your answer as 30. Now, we are not given units for this question. We don't know whether it's centimeters, whether it's kilometers, whatever. But we should show the examiner that we know the units of an area. In fact, even if we're not given, we should always indicate some form of unit. In this case, you can always write unit. And then we know that that unit, because it's an area, it will be a unit squared. So for the area, it will be very important to indicate that you have an understanding that the unit of an area have got an exponent of 2. Even if we are not given an exact unit, but you are indicating that whatever unit that you would have there, it would have an exponent of 2. That would show that you know what you're doing. Then on 1.3, we need then to calculate the size of angle theta. We now need to calculate the size of angle theta. This becomes very, very easy because now there is our theta there. You can clearly see that our theta is an obtuse angle. So our formula becomes theta is equal to 180 degrees minus the arctan of the negative gradient. There is not much that we need to do now because the gradient that we are worried about, it is the gradient of the line QP, which we calculated here earlier on. So we can just take out this value and substitute it into that equation, and then we get our theta. So theta will be 180 degrees minus the arctan of minus, which is from the formula, but the gradient is coming with its own negative. So it becomes minus 3. And if we punch that in our calculator, we'll get 108,435 degrees. And you can see this is an angle that exists between 90 degrees and 180 degrees. And therefore, it agrees with the fact that theta is an obtuse angle. Right. We are almost done. So be patient and continue to enjoy the lesson. Point 1.4, or question 1.4, we are going to determine the coordinates of M, which is the midpoint of QR. The coordinates of M, which is the midpoint of QR. Fine. So we know that our midpoint formula is capital M, and we are looking at the midpoint of line QR. So we can indicate here that we are looking for the midpoint of QR. Let me remind you here that here for the midpoint, we use capital letter M. So the midpoint, it is, because it's a coordinate of the midpoint, it will be x1 plus x2 over 2, and then y1 plus y2 over 2, and we close that bracket. So if I take this as the ones, so it becomes minus 4 plus 7 over 2, and then for the y's, I'll have 2 plus minus 1, which is 2 plus minus 1, again over 2. And then we can always punch this in our calculator. It gives us 3 over 2, semicolon, 1 over 2. And then this becomes the coordinates of the midpoint of the line QR, which from our question, it would be somewhere there. And then we are done with that question. Right, so we are doing the last part of the question where we are going to determine the equation of the line MN, which passes through M, the midpoint of QR, and is also parallel to PR. Let's go to the board and see how this pans out. So this line that we are dealing with will be parallel to the line PR. It will pass through M, the midpoint of QR, and passes through another point M somewhere. Let's put maybe N will be somewhere there. So we are talking about a line like this, which will pass through the midpoint of that point and through another point, says there, which is N. And this new line is parallel to that line. We already know the coordinates of the midpoint from our previous calculation. Right. We did calculate the gradient of PR in our first calculation, and we found that to be 1 over 3. Therefore, if this line is parallel to that line, it means the gradient of NM, the new line, is also going to be equal to 1 over 3, because these two lines, they are parallel. Then we have got what we need, the gradient of the line and a coordinate where it passes through. Then let's substitute that into our equation. Y minus y1 is equal to mx minus x1. This gives us y minus y1, which is 1 over 2, is equal to m, which is 1 over 3, in brackets x minus x1, which is 3 over 2. Then how does this pan out? It becomes y minus 1 over 2 is equal to 1 over 3x, then minus 1 over 2. Then we take and transpose the negative half. Therefore, y is 1 over 3x minus 1 over 2 plus 1 over 2. This gives us y is equal to 1 over 3x. These will cancel out, and then that becomes the equation of the new line, which is y is equal to 1 over 3x. So this is how you would tackle a typical examination question, which deals with all the concepts that we have covered in this topic of shape, space, and measurement. I hope that you have enjoyed this series of lessons, and therefore I'm going to leave you with another typical examination question, which will give you and expose you to more practice. Until we meet again, have a wonderful time.